The James Webb Space Telescope, JWST, much of the time hailed as the substitution for the Hubble Space Telescope, has changed how we decipher the universe since its send-off. The telescope has given a remarkable point of view on the universe, uncovering privileged insights and uncovering sights already inconspicuous by humanity. The JWST's state-of-the-art innovation has permitted researchers to look into the farthest reaches of room, investigating worlds, stars, and planetary frameworks shaped billions of years prior. This paper digs into the many elements of the JWST, from its mechanical miracles to its earth-shattering revelations, and examines how it has reshaped how we might interpret the universe. Value the meaning of the JWST, it is fundamental to comprehend its ancestor, the Hubble Space Telescope. Sent off in 1990, Hubble furnished stargazers with the principal clear pictures of far-off worlds, nebulae, and stars, liberated from the obscuring impacts of Earth's climate. Hubble's commitments to science are inconceivable, from deciding the pace of the universe's extension to noticing the accident of Comet Shoemaker-Doody 9 with Jupiter. Its profound field pictures, catching light from systems billions of light-years away, have given us a brief look into the early universe. Nonetheless, notwithstanding its triumphs, Hubble had constraints. Its essential mirror, with a 2.4-meter width, restricted its light social occasion capacity, and its instruments were intended for bright, noticeable, and close infrared pieces of the range. As stargazers pushed the limits of our insight, obviously another telescope was required, one fit for finding in the infrared range, where it could look through enormous residue mists and notice the universe's most memorable galaxies. The thought for the James Webb Space Telescope started to come to fruition during the 1990s, even before Hubble had arrived at its maximum capacity. Named after James E. Webb, NASA's overseer during the Apollo period, the JWST was proclaimed as the following extraordinary observatory: a telescope that would look further back in time than Hubble, catching the light from the primary stars and universes that framed after the enormous detonation. The JWST's plan presented critical designing difficulties. Dissimilar to Hubble, which circles Earth at an elevation of around 570 kilometers, the JWST would be situated at the second Lagrange point, L2, around 1.5 million kilometers from Earth. This area offers a steady climate with negligible impedance from Earth's intensity and light. However, it likewise implies that the telescope can't be overhauled or fixed by astronauts. Notice the weak, far-off objects it was intended to study. The JWST required a lot bigger mirror than Hubble. The arrangement was a section mirror made of 18 hexagonal beryllium fragments covered with gold, providing the telescope with an all-out breadth of 6.5 meters. This mirror must be collapsed to fit inside the Ariane 5 rocket that would send off it and would just unfurl once the telescope arrived at its objective. The JWST likewise required a sun shield to hinder intensity and light from the Sun, Earth, and Moon, keeping the telescope's instruments at their working temperature of only a couple of degrees above outright zero. The sun shield, the size of a tennis court, is made of 5 layers of an exceptional material called Captain, which can endure outrageous temperatures. After long stretches of arranging, deferrals, and cost overwhelms, the JWST was at last sent off on December 25, 2021. The send-off was a pivotal event, watched by researchers and space lovers around the world. The Ariane 5 rocket conveyed the telescope into space, and over the course of the following 30 days, the JWST set out on a complex and carefully arranged succession of organizations. The telescope's sunshield was the primary significant part to convey, a cycle that elaborate many components and large number of parts working as one. Any disappointment might have destined the mission. After the sunshield was effectively conveyed, the mirror portions started to unfurl and adjust themselves. This cycle required a while, as each section must be situated with nanometer accuracy. By mid-2022, the JWST had finished its arrangement and adjustment, and its instruments were prepared to start catching data. The first pictures delivered to people in general were out-and-out fabulous. The telescope's capacity to find in the infrared uncovered the universe in another light, with shocking clearness and detail. One of the essential objectives of the JWST is to notice the primary systems that shaped after the huge explosion, billions of years prior. These cosmic systems are far off to such an extent that their light has been extended into the infrared range because of the extension of the universe, a peculiarity known as redshift. Hubble could witness these antiquated articles, yet the JWST's infrared abilities permit it to see them in extraordinary detail, and its most memorable year of activity, the JWST made a few noteworthy disclosures. One of the most critical was the recognition of worlds that existed only a couple 100 million years after the enormous detonation. These cosmic systems showed up more monstrous and created than recently expected, testing existing hypotheses of universe development and advancement. Researchers had long accepted that the primary systems were little and gradually developed over the long haul by converging with different worlds. Notwithstanding, the JWST's perceptions recommend that a few universes framed significantly more quickly and turned out to be huge sooner than anticipated. This finding has incited stargazers to re-examine their models of how worlds structure and evolve. The JWST additionally caught pictures of vast designs that had never been seen. For instance, the telescope noticed the perplexing subtleties of the inestimable web, a tremendous organization of fibers that interface cosmic systems across the universe. These fibers are made of dim matter and gas and are the framework whereupon cosmic systems structure and develop. The JWST's perceptions of the astronomical web have given new bits of knowledge into the huge scope design of the universe and the job of dull matter in molding it. The JWST has likewise altered how we might interpret star arrangement and heavenly advancement. Stars structure in thick billows of gas and residue, which block noticeable light. Notwithstanding, infrared light can enter these mists, permitting the JWST to notice the course of star arrangement in remarkable detail. One of the telescope's most memorable targets was the Orion Cloud, a heavenly nursery situated around 1,344 light-years from Earth. The JWST's pictures uncovered many youthful stars, some of which were as yet implanted in their natal mists. These perceptions have given new experiences into how stars structure and advance, as well as the cycles that lead to the development of planetary systems. The JWST has likewise noticed the last phases of heavenly advancement, catching shocking pictures of kicking the bucket stars and the nebulae they make. These perceptions have revealed insight into the cycles that oversee the finish of a star's life, including the development of white midgets, neutron stars, and dark holes. One of the most interesting parts of the JWST mission is its capacity to study exoplanets, planets that circle stars outside our planetary group. The telescope's instruments are equipped for examining the climates of these far-off universes, looking for indications of tenability and possibly life. In its most memorable year of activity, the JWST made a few critical disclosures connected with exoplanets. One of the most remarkable was the identification of LHS 475b, an exoplanet situated around 41 light-years from Earth. This planet is generally similar size as Earth and circles its star in only 2 days. The JWST's perceptions uncovered that LHS 475b has a thick environment, perhaps made out of water fume, carbon dioxide, or methane. The JWST has likewise noticed other exoplanets with different climates. A portion of these planets have thick, cloudy environments wealthy in methane and different hydrocarbons, while others have clear climates overwhelmed by hydrogen and helium. These perceptions have given significant information on the variety of planetary frameworks and the circumstances that could uphold life. One of the most fascinating inquiries in space science is whether life exists somewhere else in the universe. While the JWST can't straightforwardly identify life, it can look for biosignatures, compound markers that could show the presence of life. For instance, the recognition of oxygen or methane in an exoplanet's air could propose the presence of natural cycles. The JWST's capacity to study exoplanets has opened another time in the quest for life past Earth. As the telescope keeps on noticing more planets, it will give critical information that could be useful to address the deep-rooted question: are we alone in the universe? In expansion to its investigations of far-off worlds and exoplanets, the JWST has caught pictures of the absolute most gorgeous and strange articles in the universe. One of the most striking is the grandiose tarantula, a huge star-shaping district situated in the enormous Magellanic Cloud, a satellite system of the Smooth Way. The infinite tarantula, otherwise called 30 Doradus, is a huge locale of gas and residue where a large number of new stars are being conceived. The JWST's pictures of this locale uncover unpredictable fibers of gas, sparkling groups of youthful stars, and the remainders of cosmic explosion blasts. These perceptions have given new experiences into the cycles that drive star development and the existence patterns of gigantic stars. The JWST has additionally caught amazing pictures of nebulae, for example, the Carina Cloud and the Falcon Cloud, uncovering subtleties that were recently stowed away from view. These pictures have charmed the public's creative mind as well as given important information to cosmologists concentrating on the birth and passing of stars. While the JWST has taken unbelievable steps in how we might interpret the universe, its process has not been without difficulties and discussions. The telescope's improvement was tormented by postponements and cost overwhelms, with a last sticker price coming to almost $10 billion, essentially higher than the beginning.